Let me welcome you to this course on fluid mechanics, and I will go through a brief overview of this course so that you are familiar with what we are going to cover. Now, it is very important before entering into any course to discuss that why are we studying the subject, and as engineers or as engineering students, you must have been fascinated by many of these applications, which I will discuss in more details in my lectures, like automobiles, standard cars, sports cars, spacecrafts like airplane, rockets, sports ball dynamics like the dynamics of tennis balls, cricket balls and all these things. So, all these are broadly in the purview of fluid dynamics. All these designs are broadly in the purview of fluid dynamics. Power and process plants, so emissions from power and process plants, the technologies behind running of the power and process plants, typically all the pipings, the fittings, the pumps, turbines, all these types of devices, and also very interesting natural phenomena like phenomena taking place in tornado, river, raindrops, and also in animals like butterflies, snakes, fish, how they swim, all these kinds of phenomena, and not only in nature but also in human body, like a whole lot of medical science is driven by fluid mechanics, like respiratory system, pulmonary and cardiovascular system, sperm swimming, all these are driven primarily by the governing laws of fluid mechanics. And something which is not so peaceful like nuclear explosion, that also is governed by fluid mechanics. So, it is not an exaggeration to say that fluid mechanics is related to each and every facet of life, and not only fluids, you also have interactions of fluids with structures. So, fluid structure interactions are common, and something which is also very interesting is that there are many fluids which are not in the classical sense behaving like water, but like thick fluids, so to say. I mean, sometimes it is very difficult to distinguish between food and drinks, like something which is soft like a gel type, whether it is a food or a drink, it is up to you to decide, but these are the kinds of materials which are discussed in the fluid dynamics paradigm. And even something which is not so fluid, like this example is an example of a traffic flow, and this traffic flow is many times governed by the basic laws of fluid dynamics or fluid dynamics type. Sometimes we study fluid mechanics not just because of the applications, but because of very interesting and beautiful fluid flow patterns. These are that are associated with the fluid flow that you can see through these examples, and many more examples which are not so traditional, like so we can say broadly that fluid mechanics is everywhere. Like it is very difficult to isolate areas where fluid mechanics is not there, and even if we talk about modern examples like micro scale fluid flow, nano scale fluid flow, microfluidics, nanofluidics, which you can use for cooling of microchips, or even with the same technology you can use for medical diagnostics in a portable device, in a rapid diagnostics paradigm. So, all these examples are broadly classified under the common paradigm of fluid dynamics. You can refer to many other examples in biology, like this example you can see rapid DNA hybridization, which is an example borrowed from the classical biological scenario, and in these kinds of examples also you can see that fluid mechanics works. You can track the dynamics of a biological cell in a fluid flow environment, and you can see that in such a scenario also the fluid dynamics, the shear on the cell, how it affects the adaptability of the cell, it works. Then there are several other examples which can be very interesting and fascinating. For example, by mimicking a mosquito's bite, you can design a microneedle for blood extraction and drug delivery. Now, how this device works? This device works on the basic principles of fluid dynamics. So, fluid dynamics, it is very important that there is a great level of motivation. So, we have understood that why we will learn fluid dynamics, and I will briefly touch upon what we will learn. See, we will learn of course certain chapters, we will go through certain protocols to learn the grammar of fluid mechanics, but fluid mechanics is often very amazing, it is beyond the protocols, many times it contradicts common intuition. So, let us go through these, like rough surfaces may reduce frictional resistance instead of acting as hindrance. Without friction, birds cannot fly and fish cannot swim. Symmetric problems may have asymmetric solutions, and presence of particles in a flow may reduce the effective viscous nature of the fluid. A highly viscous flow may be a good simulator of ideal flows with zero viscosity, and time dependence of flow depends on the choice of reference frame. Not only that, there are many other non-intuitive examples, like shear force may vanish although shear stress may exist. So, many of these examples are very amazing, and these will contradict our common intuition, and learning science is about learning those examples which contradicts our basic intuition. So, the general perspective of studying fluid dynamics is of course combination of experiments and theory, but because this is an online theoretical course, we will mainly be discussing on the theoretical facets. And to conclude the overview of this lecture, I will give you a lecture outline. This is the outline of the lecture lecture series that we will be having for this online course program. In the first week, we will be discussing introduction and basic principles. In the second week, properties of fluids. In the third week, continuation of properties of fluids and fluid statics. In the fourth week, again fluid statics. Fifth week, fluid kinematics part 1. Sixth week, fluid kinematics part 2. Seventh week, dynamics of inviscid flows, so mainly Euler's equation and Bernoulli's equation, and week 8 continues with it. Week 9, 10 and 11 integral forms of conservation equation. So, basically this deals with the Reynolds transport theorem, and week 12 dynamics of viscous flows, which will briefly introduce you to the Navier-Stokes equation and its applications. So, these applications may concern some of the typical examples associated with the pipe flow. So, this will be the purview of the basic fluid dynamics course that we will be offering in this semester, and if things go all right, in the subsequent semester we will be having an advanced version of the fluid mechanics course, where we will be covering more advanced topics which will be a continuation of these lectures. So, I hope you will be enjoying these lectures, and we will try our best to satisfy your interest. Thank you very much for registering for this course, and I look forward to having fruitful interactions with you. Thank you very much.